Don't try what you're about to see at home.
On this episode of Mythbusters,
Hey, look at that!
Adam and Jamie investigate the science behind the candy and soda sensation that's sweeping the internet. Like chemistry super sleuths, they bust the culprits behind the cola cascade.
No CO2, no foam.
And they can't resist using the gassy geyser for some Mythbuster madness.
Cue dramatic music.
All right, guys, I've got a fun little experiment for you to try out. I was just doing this photo shoot with FHM, and it seems to coincide with an internet phenomena of people taking 2-liter bottles of soda and dropping chewy candies into it for boom, big explosive.
Yeah, I've seen that. It's all over the net. It creates some kind of geyser that comes out the end of the soda bottle, right?
Yeah, and every time I've seen it on the web or on television, they've trot out an expert to tell us why it happens. And all of their explanations are amazingly different. None of them agree with each other.
So we're not going to test whether or not this occurs.
No, we know that it occurs.
Yeah, we're going to have to check out whether these various explanations are correct, though.
And which one is correct, if any.
Okay.
It's a ton of fun, but the Mythbusters' mission is to find out exactly what's going on inside that bottle.
Hey, look at that!
Well, amid the chaos, it's clear that this foamy fountain has something to do with the cola's fizziness. And to find out more, it's over to our resident fountain of knowledge.
The gas component of this soda is CO2. And we want to know what role it plays in this cascading effect that we see when we drop these candies in. So the one way that I know of to figure this out is to actually remove the gas. We should be able to do that by just agitating the soda until it fills up this balloon. And then once we've removed all of the gas, if we drop the candy in and we don't get any reaction, we'll know that it was because of the gas. Let's see what the candy does now. Not a thing. No CO2, no foam.
So carbonation is the first crucial ingredient on the cascade checklist. But surely there's more to this Mentos mayhem.
What's up?
Well, we need to determine what else other than CO2 is at play here. So
If anything.
If anything. So this is plain soda water, and all it's got in it other than water is CO2.
Well, and this is the Diet Cola, and it's got the whole bunch of other stuff. So if CO2 is the only factor, these two things should spurt the same height.
Yeah.
All right, let's try them out. Ready? 2, 1.
Well, that's pretty clear.
That's pretty clear. The Diet Cola, there's definitely something more going on than just the content of CO2 in the candy. Because the Diet Cola went like 5 or 6 times as high as the soda water.
So CO2 is not the only culprit in the cola cascade. The plot thickens.
I've got aspartame.
Armed with the constituents of Diet Coke, how's he going to use them?
The soda water is our test bed. It's our basic unit of measurement here. I will be adding each of these ingredients one at a time to individual bottles of this and trying it out with the candy and seeing if I get a more vigorous response than just the soda water alone. If and when I do, I may find out that it's chemical D that provides the most vigorous response, and we can say, oh, there's your culprit.
That's the plan. And first up is A for aspartame, Diet Coke's artificial sweetener. Adam makes up a solution of the sugar substitute, adds it to the soda water, and gets ready to drop in a Mentos. It's a craze that was kicked off by our very own bubbly Mythbuster. Add some Mentos to some Diet Coke, and you get a cascade of swell proportions. So, what will happen with the sweetener added? Sweet. The sweeteners made the cascade 20 times higher.
Now that's interesting.
That's a much more vigorous reaction than the soda water alone. Aspartame is doing something to the water.
But what about the other main ingredients? First, the acids. But neither the citric acid nor the phosphoric acid excite any alchemy, or for that matter, Adam.
Caffeine, potassium benzoate, and aspartame all had pretty much identical reactions.
So, Adam and Jamie have isolated the key active ingredients in the Diet Coke. Next, they're going to find out what the Mentos bring to the Cascade Carnival. Gum arabic and gelatin.
Let's pour in this gum arabic and see if it makes the water want to release more CO2 faster. And so it does. Look at that. I'd call that a reaction.
Sure enough, both of the ingredients cause bubbles to burst forth. But there must be more to the Mentos magic than that.
The most common theory about what's going on in this reaction between the candy and the soda is what's called nucleation. Basically, the idea is that the surface of the candy is covered with microscopic pits and lots of more surface area than you can actually see. And each little pit, each little corner provides what's called a nucleation site, or a place where a carbon dioxide bubble can form and escape.
Look at a Mentos close up, and it's like the surface of the moon. And that might be the candy key. Drop one in cola, and every tiny crater provides a site where a CO2 molecule can change to gas. Because Mentos are so pitted, the theory is that millions of CO2 bubbles are formed in a very short space of time. And because the candy sinks and this rapid release of gas happens at the bottom of the cola, you get that famous fountain. To test this nucleation theory, they're going to start with a control. One regular mint Mentos dropped in soda water. And sure enough, it gets the bubbly party started. Now, to do a comparison.
These two candies are made by the same manufacturer, and as far as I'm aware, even using the same process. But the colored version of this actually has a glazing over it. It's a wax coating or a sealer that inhibits the nucleation process that the other one achieves quite readily.
The shiniest surface should lower the nucleation sites, meaning less of an immediate eruption.
That's not doing anything more than the wall of the plastic bottle itself.
Sure enough, with the smooth Mentos, there ain't no whiz with the fizz, proving that nucleation is the prime mover on the active ingredient checklist. And with all the culprits exposed, the Mythbusters can say they finally cracked the case of the candy and cola cascade.
So you guys come up with anything? What causes a reaction?
Yep, we sure did. And we also busted everything that we've seen in the media, because not a single one of them came up with a complete explanation of what is going on with this soda.
They all had a piece of the puzzle. In fact, it turns out that it's a combination of most of the explanations we've read. The primary initiator of the reaction is nucleation, the candy helping bubbles to form in the soda. But it turns out that the ingredients that make up the candy match perfectly with the ingredients that make up the soda to create what's called a cascade effect, whereby the soda wants to let go of all of its CO2 instantaneously. And that's what makes the explosion happen.